Okay, let's put it all together now and solve the NFL jersey problem. Remember our situation here. We're selling NFL replica jerseys. We have an 8-week period where we can sell them. The expected demand during that time is normally distributed with a mean of 32,000 and a standard deviation of 11,000. I buy the jerseys for $10.90 each. I sell them for $24 a jersey, and I want to know how many units to buy. We looked at two different cases, and the cases differed whether I assumed a salvage value of 0 or a salvage value of $7 a jersey. In each case, the critical ratio was determined by the price minus the cost over the price minus that salvage value G. And so we found what the Q stars would be. And as expected, if I have a salvage value, my Q is going to be bigger. In this case, it's 40,149 compared to 33,267 without that salvage value. Okay, so what is the expected profit for each case? So we're going to use this expected profit equation that we were just talking about. And here it is. And there are 3 terms for this. And so let's calculate each of the terms for each of the cases. So this first term is just the expected demand, that EX, expected demand over that period. And you notice that it's the same for each of the 2 cases because how much I order the salvage value doesn't change the demand over that time. And the only difference is what I multiply it by. P minus G, 24 minus 0 for case 1, 24 minus 7 or 17 for case 2. And you can see I get $768,000 for case 1 and $544,000 for case 2. Okay, let's go to the second term. And now this differs for each of the 2 cases because the Q's differ. And I'm going to multiply each of them by its C minus its corresponding G. And you can see the values I get. $362,610 for case 1, $156,581 for case 2. Now let's get to the third term. And for this, we're going to have to focus in on this expected unit short. So we're going to use this unit normal loss function, this G sub k, to find the expected unit short because we have a normal distribution. So let's focus a little more into that. So we're going to be looking at this third term, and how are we going to find this expected unit short? We're going to transform our demand distribution into a standard unit normal by subtracting off the mean and dividing by the standard deviation. We're going to look up and calculate the G sub k for that k that we just determined. We're going to multiply that G sub k times the standard deviation of our demand to transform it back into units for our distribution. And then we're just going to multiply it by this term to find the value of the third term of the profitability equation. So for the first case, we know the Q star is 33,267. We can find the K, just a straight transformation. Take that 33,267, subtract off the mu, or the mean of the normal distribution, divided by the standard deviation. I get 0.115. I can calculate in a spreadsheet what that means in terms of the G sub k. It'll give me a G sub k of 0.3441. Check the math, play along at home. But let's also look at the standard normal table because this will make us do some interpolation, something that people don't do as much these days. So here's my table. You should be very familiar with this. I've got a K of 0.115, so I want to find my G of 0.115. And I know it's going to fall between these 2 values. And so what do? Well, I know that the K, 0.115, is right in the middle between 0.11 and 0.12. So I can probably find the G sub k that's right in the middle of these 2 values, the 0.3464 and the 0.3418. So this is interpolating. I take half that distance, and it's going to be 0.023, and I can either add that to the 0.3418 or subtract it off of the 0.3464. And so I'm just going to add it on to the lower one, and I get 0.3441, which is the same thing I got by using the formula in a spreadsheet. Okay, so I have my G sub k. The next step is to find my expected unit short. And now I'm just transforming it back into my distribution instead of the unit normal distribution. So I'm multiplying it by my sigma, my standard deviation of the demand. And so it's telling me I can expect to be short 3,785 jerseys each 8-week planning sales period. So multiplying it by this P minus G plus B term gives me 90,840. So case 2, with my higher Q star, with my salvage value of $7 a jersey, follow the exact same steps and you can see what it goes down to. Check the math at home, make sure you come up with my same numbers. And again, you can either use, for finding your G sub K, you can use a table or you can use a spreadsheet. So let's put it all together. Here's my expected profit equation with the 3 terms that we just talked about. And I calculate them both for the case where I have no salvage value and the case where my salvage value is $7 a jersey. And then here in the last column, you see what the expected profit is. And that's simply the sum of the first term minus the second and third terms. So what you should notice here is that the profitability for the second case, where I have a salvage value of $7 a jersey, is about $50,000 more than the expected profit when I don't have that. That seems to make sense, but let's look a little deeper and let's expand this profit equation, as I had done previously, into these 4 terms. And so this term that I'm highlighting, the expected demand minus the expected units short, is actually the expected units that I sell at the full price. This term that I'm highlighting here, the Q, the order quantity, minus that expected demand minus the expected units short, is the expected number of units that I sell at a discount. What's interesting is, as I add a salvage value of $7 a unit, notice the expected demand doesn't change, right? Because that doesn't change. But what changes is the amount that I order. And as I order more, not only will I be able to sell some at discount, 9,614 jerseys more at discount than I would have at the case where I don't allow it, but the amount that I sell at full price goes up by a little over 2,000 jerseys. So by having this salvage value, what does that do? That increases my Q because the downside is much lower for having more inventory. So having excess inventory doesn't cost me as much, so therefore I'm going to order a little more. If I order a little more, then I'm going to be able to capture more of that demand that I'll be able to sell at full price. So not only having salvage value, not only does that increase the number of units I can sell at a discount at that salvage value of $7 per jersey, it also increases the amount of demand that I capture for selling at that full price.